Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication.
Yeah.
Hello, everyone. It's Joe Fairley from Ascent Fabrication. You are listening to the Fabrication Friday podcast. Today, we have a very special guest. We have Peter from OMD 3D. Peter is out of Belgium. We're getting quite the international list of contacts now. We've got Peter from Belgium here. He is with the company OMD 3D, which is kind of an all-around 3D printing development and manufacturing and service company. I'm sure he's going to do a very nice job here of explaining all the different things that OMD 3D is involved in. So thank you very much for coming on the podcast today, Peter. We're very happy to have you here.
Okay, no problem. No problem. Yeah.
Yeah, so give us a little bit of an introduction into yourself and kind of how you kind of came into the 3D printing industry in general.
Well, I'm actually an aircraft engineer. And I started my independent business when I was 23. Did a lot of machine development, product development for various industries, dredging industries, shipping industry, heavy steel and everything. And actually around about 20 years ago, I was planning to buy my first 3D printer. That was then, the only available commercial machine on the market was the Stratasys machine. It was an extremely huge machine that could print, the size of a coffee cup.
Sure.
And it was extremely expensive, so we didn't buy it. We said, okay, let's wait for a moment because it was extremely big. I think it was around about 7 million Belgian francs in that time, so it was extremely expensive. So but around about 10 years ago, the need, and we kept on following it, then the need for a 3D printer on the desk. When you are developing, we are tactile people, so you need to be able to hold something in your hand, check it by hand and everything. And we bought our first commercial available 3D printer, and that was a Leapfrog 3D printer from a Dutch company.
Okay. Yeah, it seems like a lot of those early printers came out of the Dutch region, right? We had Ultimaker come onto the scene pretty early on. Yeah, Leapfrog, that was the name of that one?
Yeah, Leapfrog. It worked. It was not a super machine like all those machines in that time. It was a very basic machine and whatsoever. So, but that's how actually we started with one machine. And then all very, very, very soon, a lot of customers knew we had a 3D printer, so we started taking jobs in for customers. And then I was left again at the point that I didn't have any machine for myself to be able to see my designs. So a second machine was bought, and you know how it goes. It's cascading. So we are running around about 35 machines for the moment.
You're running 35 machines now, or that was back then?
No. Now we are running around about 35 machines. In now, few SLA resin printers, sandstone 3D system, full color machine, and then various filament printing machines with, for the moment, the biggest envelope of 1.20 meters by 60 by 60.
Yeah. Okay. Very nice.
Yeah. We are running. We calculated. We are running for the moment around about 1,200 kilograms of filament a year in print service. So that's a bit how we yeah, it was an accident. We stumbled into it. We are still engineering company, and I really want to stay engineering company.
Sure.
But yeah, the print service, once everything is sliced and everything is running, you don't have to do that much anymore. So it's doable. Yeah.
So who would you say is kind of what industry is your biggest customer, and are they in Belgium or are they somewhere else in Europe or somewhere else in the world?
Nope. Let's say we do round about 10 to 15% for Belgian customers.
Okay.
All the rest is abroad. We are doing print service for the United States, Brazil, Dubai, Finland, Holland. It's very close. And then France is very big.
Okay.
Italy, we are all over the place.
Yeah.
Belgium is a very small country, so there's not a lot of business. There's not a lot of business to do in a country that is only 300 kilometers wide. So,
yeah.
So and a bit due to COVID, also we had to expand. Everything came to a stop, and then we had to go onto the international market, and it actually exploded a bit. Let's say it exploded a bit. It's good, but it goes far for the moment. Yeah.
Absolutely. That's great to hear. What kind of industries are you mainly in with that print service specifically?
Well, we are running 95% business to business. Absolutely. So it's very rare we have to do some small print jobs for schools or for private persons. And we have a few electronics customers, a few automotive customers, orthopedics, not that much because we don't have the profession of orthopedics. I'm a mechanical engineer, so I only can print what they send us. We can't make the files or whatsoever. Building and construction companies, it's actually very various. We have a few metal foundries also where we only make masters to do the sand casting. So it's very different.
That's great.
It's very interesting, but it's very different. Yeah.
So with that print service, and you mentioned that you have developed some of your own, engineered products yourself. What kind of design software are you using?
I'm running, let's say, for 90% of the things we are running SolidWorks. Yeah, we are running SolidWorks. We have a Fusion 360 license, but actually we use the Fusion 360 license for some things that SolidWorks has problems with. Like every CAD software, there is something that doesn't work like you want it to. And for the sculpting, so for the 3D sculpting and the more, let's say, organic shapes and everything, we use ZBrush. Yeah.
ZBrush too. Okay.
Yeah.
Do you use Mesh Mixer for anything?
We are rarely.
Rarely.
Yeah.
It's just interesting to see what everyone is using and for what purposes. ZBrush is completely free. Is that right? Or is it?
No, it's paid. We have a paid license.
Oh, okay.
We have a paid license, and we actually started off using ZBrush because of some limitations in Mesh Mixer.
Sure.
We started off with Mesh Mixer. It's completely free. It's open source, everything. Sure. But yeah, it's like everything. It has limitations. So that's a bit why I went to go and see for the ZBrush. Because if we have to print in full color on our sandstone printer, I am able to design all colors in, send the file to the slicer for the machine, and have all colors printed. And that's a possibility we didn't have in the Mesh Mixer, so that's a bit
right. Yeah, no, we use it quite a bit for our orthopedic and prosthetics and orthotics oriented designs for all those custom devices, but using kind of a hybrid approach between Fusion 360 and Mesh Mixer sometimes. I've I've only dabbled in ZBrush a little bit, but definitely seen some other people come up with some pretty nice designs, and have seen that the color aspect of it really be an interesting one.
Yeah,
to pull
yeah.
off.
The learning curve from my point of view to learn ZBrush at a let's say at a late age. I'm 54, so at a late age, starting to
Oh yeah,
learn ZBrush, it's a steep learning curve.
sure.
The possibilities are so damn enormous, and yeah, we are millimeter people. We are engineers, so
Sure. Yeah.
there is a problem. At
Yeah.
some point, it has a problem. I actually start designing for ZBrush in SolidWorks. So I start making my basic design in SolidWorks, basic shapes. So I'm completely sure that dimensions are correct.
Right.
And then we transfer that file to ZBrush and start off with that. So we are, from the beginning in the ZBrush design, we are sure that all dimensions are like I want it to be.
Right.
So that's a bit, perhaps it's not a good way to do it, but for me it works. Yeah.
Right. Yeah. I mean, same kind of thing we do in Mesh Mixer. If there's anything very specific that we need to design, it's going to be in Fusion 360,
Yeah.
because of the limitations of those measurement features in Mesh Mixer. Right. They're really not useful, except for maybe seeing the scale of something in the unit dimensions. But other than that, but it can be pretty powerful for some of the organic shapes that we're making that we don't need to necessarily know down to the millimeter of what they are.
Yeah.
But no, that's interesting. So with you've got the printing service going on at OMD 3D. I know that you're connected with a few of the other 3D printer companies, right?
Yeah.
What couple companies do you have cooperations with?
Well, we have a very long-standing cooperation with Colorfrap from Holland. We started off as materials reseller for them, and we have a very good relationship with them. And we also started as reseller for the Blackbelt printer at some point. So we were reselling Blackbelt for a few years. So that's one. In January 2022, actually, we took over all activities of Blackbelt. So we are now the producer of Blackbelt machines. So we are actually producing the standard machine that was existing, plus a lot of new add-ons, to improve quality, to improve functionality and whatsoever. So that's the Blackbelt story. And then we are already, I think, around about 6 to 7 years reseller for Belgium and a part of France also for Modix printers.
Okay.
Which actually is a very nice, affordable machine with a lot of possibilities. It's a very nice machine. They have a nice range of machines also. So it's, for the price, it's a very high quality machine, actually.
Right. What do those tend to run, and how big are those machines again?
Well, the biggest machine we are running here is the Modix 120. So we have 1 meter 20 in X axis, 60 centimeters in Y, and 60 centimeters in the Z axis.
Okay.
The biggest machine available for Modix is the 180. So it's 1 meter 80 long by 60 by 60. But what we see is that the machine that is for the moment going the best is the big meter. So you have a cube of 1 meter 50 centimeter 5 centimeters. So you can print 1 meter cube parts.
Okay.
Now with IDEX extruders, so you have a 2 IDEX tool heads. It's a fantastic machine. It's a nice envelope for those guys who want to make shares or whatsoever. In 1 meter envelope, you can put already a lot of parts. Sure. Or rather big parts for furniture. And everything. It's a nice machine with a reasonable price. So it's fantastic.
Yeah, that's quite interesting.
Yeah.
What kind of hot end do they have on there? Nozzle size?
Well, they used to have the E3D hot ends, the Titan Iro, I think, something like that. But to be honest, it's a rubbish extruder. For us, we are running. For
The
us,
extruders are coming along. I feel like they've lagged a little bit.
yeah. For us, running a machine 24/7. Yeah, I already own a lot of stock options from E3D by changing extruders every other week or every 5 weeks because everything is worn out and everything. So
Yeah.
yeah, but Modix has now its own proprietary combination. So they use the Bondtech extruder.
Okay.
It's a fantastic, but with a Griffin hot end. So it's their own hot end. They developed together with the guys from Slice Engineering
Okay.
from
Sure.
Canada. So they go up to 1.2 millimeter standard. I'm running one machine with a 1.4 millimeter nozzle also. I made myself, but yeah.
Yeah, of course you did.
So we actually drilled the standard one out, and actually, but it really works. It's fantastic. Almost no more clogging, even for flexible materials and whatsoever. It can run 24/7 without actually having huge problems.
Very nice.
Yeah.
I'm definitely getting more and more interested in printing big. You see the Filament Innovations machine behind me here. This is just their smallest printer that's now out of date. They continue to go larger and larger. They're actually coming out with a new 1 meter cubed printer as well.
Yeah.
That's going to be coming up here towards I think maybe the fall time. I think Mike said.
Pellet extrusion or pellet extrusion or with the high flow from dies filament 2.85.
I think it's going to have both, actually. I think it's going to have both options. Don't quote me on that, but if I know Mike, he's going to have everything he can into that printer. No, it's at least going to have the Typhoon from Dies Design. But I saw a picture, one of his posts recently on LinkedIn, and I think I saw a pulsar on there as well. So he's definitely getting more and more into the pellet extrusion. The new Aries printer is a beautiful machine, very large build volume as well. I saw it printing there in person in Pennsylvania about 2 weeks ago. I was down there doing a training on that printer with him, and it's a beautifully built machine. Really seamless pellet extrusion that they have kind of come up with a couple little tweaks of their own to help with reducing or eliminating some clogging and just making the printing experience overall a little bit more attainable for people. They've even come out now with their own slicer called Odin.
I know. I already saw. It seems promising. Yeah.
They're trying to make that, just very, very entry point level, easy plug and play for pellet extrusion. So that's kind of what that was built for. And, obviously able to do filament extrusion as well. But yeah, I know definitely going to want to take a look at that when that's fully available. Their new 1 meter cube printer. Not sure if that was still named the Poseidon or if he's named it something else now, but he's continuing on with the Greek mythology there to name his printers, which is pretty neat.
Yeah.
Yeah. I know you were asking about the Filament Innovations printers the other day.
I think I'm following them already. For a few years actually. So 2 years and a half. I came up to it, through Google search, like everyone else, I think, and it's very interesting.
Yeah. But and with again this kind of high volume approach toward more production status printing, I was very interested in the Blackbelt printer, and that's our original connection here. I had watched Blackbelt as they started out, as that separate company, but with you taking it on as well, you've talked a little bit about some of the improvements and enhancements and add-ons that you've had with the Blackbelt printer. So can you kind of take me through what the basic Blackbelt printer is and what that does and what its features are, and then start to get into some of those additional add-ons?
Well, the basic Blackbelt printer was and still is a machine with a x-axis of around 340 millimeters, y-axis 340 millimeters also. And then we're printing on a custom-made carbon belt, which actually almost for all materials avoids using spray or glue or whatsoever.
So it's actually carbon fiber?
It's a carbon fiber belt. Yeah, it's custom made. It's only 0.8 millimeters thick. So it's a very nice. You can have and the adhesion of most materials is superb. You only have problems with those materials that are already very difficult, like pure polypropylene can give some issues without any adhesion, like spray or glue or magic glue or whatsoever. Sure. But we managed printing filled polypropylene, so glass fiber filled or carbon filled polypropylene is a lesser problem. Even nylon, so PA12 or PA6 filled, it works. Yeah, you have to make another slice file than standard materials, but actually, we even tried several materials like polycarbonate, also that work. And I really try to have a system where you don't have to apply glue every other meter.
Right.
It's a continuous machine. It's built to run 24/7. So all components are high performance, high quality. And then if you have to sit down next to the printer to apply glue or spray or whatsoever, so we try to have a system where we don't have to use glue anymore.
Right. No, that's
not. We know it's not always feasible, but having an open machine without enclosure and all those things, so that can give you some trouble anyway. So we have two. But in the standard machine, we had two printing systems. So we had a Bowden system. And the Vario drive actually is a dual drive system. So we have a direct drive head on the gantry, and we push the material from the control unit. So there's no strain in the Bowden tube guiding the material. So you can go very, very flexible also without having problems and everything. And we obviously use 90% the Vario drive system. We don't sell a lot of Bowden systems anymore for obvious reasons. Bowden systems, they work, but yeah. And we use the DICE hot ends, so the DICE extruder, DICE hot ends, fantastic material from Canada. The nozzles also, they're tungsten carbide, so it's fantastic. It almost never clogs. If you try to print PVC, for instance, you don't want to print PVC also if you care for your health. But if you are trying to do it, it's also damn particular and very dangerous. So it starts crystallizing at a wrong temperature and everything. So and then obviously it's clogging. But
printing with PVC, that's interesting. I don't know if I've heard of anyone
do it.
Printing with PVC. You mean like just PVC piping, like that material, right?
Like the material they use for windows, for extrusion for windows and all those things. We did some tests. It is possible. It is possible to print. It's very difficult. It's very, very difficult because of the fact that the temperature line or curve, the sweet spot, is very, very precise. Too much temperature, too low. So it's very precise. But it works, but it's highly toxic, obvious. That's also one thing, and it's also very aggressive. So every part in your workshop, even not on the printer, but in your entire workshop, the day after you have printed with PVC, everything is rusted. So everything is starting to corrode after a day. So you don't want to inhale those fumes.
No.
Absolutely not.
Just okay, so definitely not worth printing PVC.
No, 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 no,
Interesting.
no, no. But yeah, for the rest, I had some for the black belt. I had some issues. As an engineer, you're always want to improve. So what we first did is we enlarged the linear guides. So we took one notch higher, the linear blocks one notch longer. So we had a more stable guideway and everything. So which is avoiding a lot of problems with the longer blocks and everything, linear guides, and also it makes sure that the machine is running way longer before you would even have to think about changing a linear guide or whatsoever. To my knowledge, we never had to change any more since we changed them. So what we changed also is the diameter of the axis of the steppen motors to a higher diameter to be sure those were stable. Minor changes to improve overall quality. What I would like is to have a machine where you don't have to do maintenance and have a lot of costs of maintenance and whatsoever. So daily maintenance like cleaning up, oil gluing the linear guides, keeping the machine clean, and for the rest, yearly check belts and everything. But so that's and I wanted to have the machine running 24/7.
Yeah.
At all
That's
times.
the key of conveyor belt printing, right?
That's the key. So if you put a reel of 25 kilos on the machine, start printing until it's over. 25 kilograms, it's already a lot of kilometers. So you go a long way with it, but that was the idea. And then what we saw is to also our resellers, questions from our resellers, questions from existing customers is there an enclosure for the machine? Because once you open the door from the workshop, draft, and then especially with non-standard, with PLA printing, you don't have any problems, but no one in industry prints with PLA.
It's funny. In the last 2 years that I've been printing, I really haven't printed anything in PLA. Although I just this week got one order that's outside the prosthetics and orthotics field for an art project, actually, where they want to be able to paint the actual parts that we're printing. So I did order some white PLA, and that's kind of what we're printing this week. But otherwise, we've got
all for painting. If you're using an industrial paint, use PETG, polyester PETG or a copolyester. It works fantastic with a two-component industrial or car paint. It works fantastic. There's a very good adhesion, so that's not an issue. No, we only use PLA for one particular customer. So it's a metal foundry customer. So we make the patterns they use for the sand casting. And we use only one brand, only one color. So the color fab PLA PHA natural, we use that for that. And there's only one reason: it burns out clean. So they burn out the model from the mold, and it burns out completely without leaving any residue, completely clean. And that's actually where we are running PVC, but for the PLA, but for the rest, no.
Interesting. So with the continuous printing that we have on the Blackbelt, kind of run me through the physics and what happens at the end of the drive, where those parts are coming off of the build plate. Kind of how does it separate from the belt, and with those couple add-ons of the roller table, kind of just run me through what happens at that instance.
Well, we have a separate heating zone. in the machine. So we have actually two zones on the belt, a heated part and a non-heated part. For some special machines we custom make for the customers, we can heat that part also. But standard, we have the printing area is heated, and then you have a let's say around about 40 centimeters of build plate that is not heated. So if it's continuous small parts you're printing, so they leave the heated zone when they are already finished, and they actually start to cool down, and due to the normal shrinkage, mostly when they come at the end of the belt, they're already loose. And if you're printing very small parts, you can put a bin under it, under the belt, or and you can collect all the parts that are running. So that's the easiest one. If you're printing long parts and long profiles, you obviously need to support what's coming out of the belt. So we have the roller table where they are transiting on, and you can continue printing if you want. Depending on your design and your material, you can print 6 meters, 10-meter profiles in one go.
Right. That's quite interesting. So there's no like scraper at the end of the bed.
There is, but mostly you don't need it. There is one, actually, a bit to prevent materials like very flexible materials to go back to the beginning of the belt, because then you're printing on top of the other one. So that's actually a bit why we have one, or we have the option to put it on. But I rarely have to use it. There's a small nick in the belt at the end that actually makes the part come loose. So the belt is not completely straight. At the end, we go a little bit lower with the profile of the belt, which detaches the part for 90% of the prints. It detaches it by itself. So that really works good. Talking about improvements, non-heated enclosure was actually the first thing we did, just to keep out draft. Have a small flexible curtain at the front of the machine, so to keep in keep out the wind and cold, and to keep in the temperature, keep it more conditioned.
Sure.
Obviously, then next thing is, when the part comes out of the printer, you have a thermal shock. So the next question from some customers was, but the roller table, can you close that too?
Let's just close everything.
So we have a closed we have a closed extension, so you can prolong the heating zone if you would like, or the conditioning by 1 meter per roller table. We for transport reasons we chose for 1 meter lengths, because if we have to send the machine to the States, we try to keep it in a 1 meter 20 length standard Euro pallet to be able to do the shipping. So that's why we chose for 1 meter roller table.
Makes sense. You've got a heated enclosure as well, right? And a heated
next step. Obviously, if you have an enclosure, next step is, and the question is, can you heat the enclosure?
Right.
Yes, now we can. We developed a separate unit actually, so we can send a separate unit to the customer who already has an enclosure or has his own enclosure, to be used to heat up the environment. So and also we use the same module to heat up, if necessary, the enclosed roller table in the more how do you call it, the machines that are having still more add-ons. It's actually the same heater unit we use for the filament conditioning and the filament drying system.
Sure.
So we have a very standard heating unit. We can even sell to put on a Modix machine if you would like to condition that environment also. So that's why I developed it completely separate, to be able to sell it as a separate unit.
Yeah, you mentioned a conditioning unit and then a drying unit, right? And can you take us through those two differences there?
Yeah, so we started having questions on for professional use, customers who want to run 24/7 and don't have a separate drying unit or don't have a separate conditioning system or whatsoever for. So in the standalone frame that was open before, we enclosed it. We have the possibility to enclose the standalone frame, and there we can put a volume in for drying the filaments. I have tested it to go up to 120 degrees Celsius, so that works fine. It's not necessary for all materials, but it is possible to go that high if necessary. And then for some materials, we obviously know we all try to print straight from the dry box,
Right.
to keep the moisture out. On the Blackbelt, it was a separate system, a separate roller that was again open in the air. So we made actually a drawer system for two reels of 4.5 kilograms to feed from inside the enclosure directly to the extruders without exposing it anymore to moisture in the air. So that unit, mostly you don't have to heat. You just have to keep out the moisture that would be able to go in. But we have the possibility, if it would be necessary, to preheat your filament up to 80 degrees.
Gotcha.
If it would be necessary. I haven't used it still yet at that higher temperature. Mostly what we do is we put that unit at 35 degrees, around about 35 degrees. And that's way more than enough to keep the moisture out and not to over dry the filament then also, because if you go too high and you over dry, it gets brittle and whatsoever. So actually what we did, it's still the same Blackbelt. We just made simple add-ons to simplify for customers or to improve the experience or to improve quality and whatsoever. So, and the latest is now we have a dual gantry, dual head. It's designed to be IDEX. It works IDEX. It works fine for printing two profiles at the same time. So you actually speed up your process by you double your production output,
Right.
with the two heads. Did some tests. It's completely possible to use a flexible material on one head, use a rigid material on the other, as long as the flow and the speed of the z-axis keeps up with the two materials. Mm-hmm. You can print a flexible material and a rigid material on the same go.
That's very nice. Yeah, having the ability to do two different materials, or that IDEX independent dual extrusion at the same time is definitely, very useful.
There's still a snag. There's still a small issue in real IDEX for belt printing, because it's actually very simple. There's no slicer available who is able to slice for a belt with two heads. So that's a bit the issue. That's a bit the issue we have. We have a machine that is capable. We did some tests. It works fantastically.
Yeah.
But there is no slicer available. So we are talking also like Mike did with Created Real to see if they are able to make us a slicer dedicated for Blackbelt.
Very nice.
Dual head. We already made triple head, quadruple heads also.
Right.
But then we statically connect those heads. So we mechanically connect those heads so they have the same interdistance like the US stacker machine works. And then you can print four profiles, 5 profiles in one go without any problems. It's the same slice as one part, so that's no issue anyway. But I would like it really to have the functionality of the IDEX. Yeah, we're working on it. So apart from slicer issues for the moment, that's actually completely operational.
Right.
What we did is, again, we designed it to be an add-on. So it is possible to sell a customer a machine with one head, with everything in the on the mechanical side already ready for a second head. So if you decide on buying a black belt and you want one head to start with, or you want to spread the costs for the machine, there is the possibility to quite easily send you the upgrade kit, do the upgrade yourself, or like you in America can do then, upgrade the machine for the customer, get it running. So we kept all those things actually as separate add-ons to be possible or not possible to buy and use them.
Okay, so the couple different add-ons there. With the dual extrusion, obviously you have the separate extruder, right? That would have to be installed. Would you go from the standard size belt to a wider belt then at the same time?
Going to the wider belt is a bit more difficult.
You'd want them to start with a wider belt to start.
Yeah, I would suggest, yes, it is possible, but it would mean that the customer will have to disassemble a huge part of the machine to widen out the chassis. He will have to change the rollers with heavier axes and all those things. He will have to recalibrate the belt again, which is not that difficult. But okay, it's a possible option, but I wouldn't suggest it to send it to a customer and to let the customer do that switch over.
Sure.
You could say, okay, we will keep one or two modules here, so we can switch over from a wide to a small machine or whatever. But I wouldn't advise a customer to do it himself.
Sure. Yeah.
For obvious reasons, it'll take you around. I think it'll take you around, for an experienced fabricator, it'll take you around about a day or two to get it completely set up again. So
yeah, you're needing that knowledge anyways, and probably not best in the consumer's hand at this point, but at least being able to adapt the machine to dual extrusion is definitely quite useful. You mentioned the IDEX extrusion, being able to do serial production to identical parts at one time, and then multi-material as well. So like we print a lot of the PP print polypropylene and their support material. So could we theoretically just use the support material on one side and their polypro on the other?
Yeah, because your support material, it's also polypropylene. It's a recycled polypropylene.
Right.
Yeah. So normally we already tried. So we printed on one side we printed with the color fab vario shore, and on the other side we printed with a standard for test reasons with a PLA PHA. So they have completely different temperatures. They have but yeah, it is doable. You have to make sure flow is okay and everything, but actually you can go with the same settings for different materials.
Yeah, that's definitely
obviously if you need a triple flow on one head on the other head, that would give you some issues for the moment, because you only use one sliced file, so that would give you some issues. You can change it manually on the machine. That's an easy one while you're going, but you will have to attend the print and be there to do it.
Right. So
but
it is someone like Creative Real.
It's still fiddling. I hope it works out with Creative Real. We did some testing already with a demo version they sent us. Still not completely convinced of that's what we need, but okay, there's some progress. Let's keep it to that. So
Yeah, absolutely. Did you mention before too, you made a machine with 4 extruders?
Yeah, we have a machine running with 4 extruders. So it's a customer who is running 24/7, only one file.
Yeah.
So it's a small part, only one file. They run lengths of around about 4 meters go every time. And yeah, they are printing 4 parts at one go because we connected them statically. It really works completely without any problems.
Interesting. So
Yeah.
that would be kind of a just a different approach. Rather than getting 2 black belt printers, you could have all 4 heads doing one simultaneous print.
Yeah, if the part is small enough, so that's an issue. Now, that's also a bit why the wider version came. I really didn't want to develop a wider machine actually, because the wider the belt, also the effect of warping and everything which is present everywhere present, we know. It's increasing the difficulty to get everything flat and everything. But with the IDEX, you have to sacrifice some x-axis to mechanically already harbor the components, so which shrunk down our 340 millimeters belt width to print on by around about 120 millimeters. So that and that's a bit the reason why the 525 came. So you have a decent width. If you are printing 2 parts at the same time, you still have a decent width to print the parts.
Right.
Yeah.
Could you print one large part that both heads are simultaneously working on, both extruders?
That slicer, that's still the slicer issue.
Yeah. Could you, I mean, have one very, wide part that takes up the entire build width, and then have, both of the IDEX extruders working kind of simultaneously. One gets out of the way while the other one goes back over a certain point.
That would be the ideal. I know many have tried. Also, many have failed to work with 2 extruders on one part. You don't see much progress into that field in the market. Also, I know there are a few companies who did some tests in the past, but to my opinion, there's none commercial available that is actually working together on one part with 2 extruders or more.
Right.
Modix did a test a few years ago, which worked and didn't work. But I don't know if they are going to continue in that field. I don't know. I don't see if the industry doing any let's say effort to develop machines in that area.
Right. Yeah, no, just an interesting thought. I think I had seen one instance of this kind of dual extrusion approach from different areas of one part. But obviously, it's a pretty tough nut to crack with the slicer that you would need to do that, all that coding in the background. Yeah, that's definitely quite interesting. There's one other feature that I originally didn't really pick up on, but I was reading back through one of the presentations you sent me a while back, and so the actual XY axis, rather the X axis, right? That can change different degrees, right?
Yeah.
So when would you do that? What are those degree changes? How hard is that to change the degrees?
Well, we have, for the moment, we have fixed angles. So we can print at 15 degrees, 25, 35, and 45.
Okay.
It's a fixed, so you set the machine at one angle, calibrate the nozzle again, and then you start printing. And if you want to change still for the moment, if you want to change the angle, you have to stop the printing process, manually reset it to another angle, slice according to it, absolutely slice according to it, and then you can restart. Because actually what we saw is that the most favorable angle to print on is not 45 degrees. So the most favorable angle for, let's say, the most success with the most parts is 35 degrees.
Interesting.
So 80% of the parts we are printing here in print service for customers and to proof concept and whatsoever, we are printing at 35 degrees. So because the biggest range of success parts is actually 35 degrees. As we know,
what kind of change is there? You know, is it bed adhesion? Is it just the way that it's laying down the filament?
the quality, actually the quality of the print and the surface and the surface and whatsoever. You can't forget that angled printing and slicing for angled printing is completely different than Cartesian. We start having problems like, for instance, in pellet printing also. The flow of your material is important, is way more critical than standard filament printing Cartesian. Once you start printing under an angle, this also is starting to appear. So printing, the flow for printing under an angle of 15 degrees and printing under an angle of 45 degrees, it completely changes. It can be that you will have to shrink down your flow at 45 degrees up to 80% of the flow you're using for a standard Cartesian. It is rather important, and because of the fact that we are printing under an angle, so you are pushing your part away from your nozzle. It gives you the learning curve is not difficult to start printing with the belt, but it is way more critical than Cartesian printing.
So it's starting out at about 45, and you said it's about 80% of the flow from, you know, general 90-degree printing. And as you go down, so say 35, do you have to decrease the flow rate then too?
No, as low as you when you go lower with the angle, you theoretically would have to increase the flow.
Increase the flow.
If you go up to 15 degrees, you're almost at zero. And then you are going very close to the Cartesian settings, actually. Cartesian settings, actually. Downside, and that's a bit, the 15 degrees shrinks the z-axis, the height of the part on the belt so damn much. You gain some speed, but you lose a lot of height of the part that you can print. Yeah, it is possible. So the black belt patent says in between 0 and 90 degrees. So no, 1 and 89 degrees. So that's where the black belt patent talks about. So we keep in those angles. What I would like to see in the future is actually to have a driven gantry.
Where you can actually change that angle as you're printing?
No, not as you're printing. When you shift from one part to another, that the machine recognizes at what angle it has to start printing, and it changes automatically and then starts homing again, recalibrating by itself, and continue the print queue.
Okay. So after
that would be very nice. That would be very nice. But it still has some, first of all, mechanical issues and then slicing issues, and but that would be very nice, would be very interesting. Because what you have now is, if you mistake your print and you try to print a 45 angle sliced print on a 35 degree angle, you will see it'll print, but it'll never be good. It'll never be okay. So the part is squeezed. And to avoid that, it would be nice to be able to recognize the file name and make sure that the angle, or at least tell the customer you're at a wrong angle. You have to use a different setting.
Yeah,
But yeah, okay, let's say
at that point, and then they go manually change it. Yeah.
Well, so but that's still future music. Let's say for the moment we are focusing on everything we did is make sure that everything works appropriately, and that all problems are out of the way. So that's a bit focus for the moment.
Yeah. So how would we make that decision then based on the different parts that we would want to print? What are some of those considerations to figure out what is the optimal angle that we should be printing it at?
I would say start off with 35 degree, make the slice. And as we all know, what happens on your screen if you check your slice will happen on the machine also.
Okay, sure.
If you have islands somewhere flying around in your slicer, it'll print in open air on the machine itself also. But a good starting point is 35 degrees. And then there are a few things where you should look at when you are slicing, where some difficulties can occur.
Mm-hmm.
But I would say I always start slicing apart at 35 degrees and check the file. If there's nothing actually going wrong or obviously not working, we run every part at a 35 degree angle.
Okay. So it's based on the geometry then of the part.
It's based on the geometry.
Going back to look at it, making sure that those slicing layers are looking like how you actually want it to print with the consistent thickness walls and whatever appropriate infill or support material then. I guess support material then too, right? Because we're printing on an angle, we don't need as much support, or if any, in most cases, right?
Not as much, or if any, absolutely. So the supports are positioned completely different than also Cartesian, obviously. And you absolutely don't need that much. If you need to support the part, you don't need that much support. I tend to design my supports myself.
Yeah, sure.
For a few reasons. If you let the Cura slicer decide where he wants to put supports, we all know they put too much support in areas we don't want it. Sure. So that's already one. So to save material, to save post processing, I usually design the support myself. So you can decide where you want it. I even design, if necessary, depending on the part, if necessary, you need to print a raft, which you don't do a lot on belts, but okay, if you need a raft to keep the part on the belt, because there's no contact points anyway, even that one I'm designing myself to be sure. We don't use that much material. For the moment the machine is running, and we have a 0.65 millimeter thickness of support and a 0.5 millimeter raft standing, and the part is actually completely supported in the air because it's curved in all dimensions. So
yeah, I have one of those parts that is coming up. Can't quite chat about it yet publicly here, unfortunately, but I was thinking this is going to be a great application for the Blackbelt printer as soon as this arrives. So I'm really looking forward to getting my hands dirty here as soon as it gets here and starting to push that to the limit for sure. So
and the most interesting also in designing your supports yourself is the air gap. You design the air gap in your for the support and the part you're designing it. So, and based on once you start, based on your experience, you will know, okay, for that material you will need 0.15 millimeters air gap. For another material you will need 0.35 material air gap or even more. And then when the parts comes off the machine, you take the support, you can take it off actually without having any scars or whatsoever.
Right.
and without extra labor of grinding, milling, or whatsoever.
Yeah, we do a lot of that already, and it's definitely
Yeah, we know.
time consuming and messy, especially when we're talking about polypropylene. If we're making those support structures in polypropylene and not the piece support material, then it's definitely time consuming to get that off of the part. But yeah, this gets back to one of my previous podcasts here. I talked a little bit more about design for additive manufacturing,
Yeah,
right? Coming up with these custom support structures specifically for your part, so that there's no question, how this part is going to be printed and how it's going to be post-processed
yeah,
cleanly and in the, least amount of labor support, afterwards. So
yeah.
yeah, that's an interesting little tidbit there. That's definitely a good key point of trying to, print something in this different way.
Yeah, yeah. But I even do that for Cartesian printing also.
Yeah,
Print,
sure.
yeah, because it saves a lot of time. You only use the material you need. You use your or you decide your own toolpath
Sure.
where the printer goes, so where you lose time or whatsoever. So I do a lot use also for Cartesian printing on Modix or on
Right.
whatever other machine. We do a lot of custom supports designed in SolidWorks while you're designing your part. What you say is very important. If you take into the considerations the way you need to print it, you can already integrate a lot in the design without having the need for support or minimizing scarring or whatsoever. Yeah.
Right.
Yeah.
Interesting. Maybe we could at some point here have a little course. Maybe we'll do a virtual online course that we record where we talk about some of these design considerations on support material design, because I think, people right now, most people who are 3D printing by FDM are just hitting that easy button in the slicer and give that a number of degrees and go for it. It's kind of nice now where a couple slicers like Prusa slicer, you're able to just paint on where
Yeah.
you want that support material. I really love that feature of Prusa.
Yeah.
Um, but that's slightly getting towards this, designing specific support materials for your
Yeah.
part. But yeah, I think you've hit the nail on the head there with wanting to minimize the amount of material that you're using, making sure that you're getting a nice clean surface finish. I'd like to kind of maybe look into that with you a little bit at a later time with maybe coming up with a design course, because I think that's a key feature that some people are getting into now, but getting out to more of the 3D printing population would be quite interesting and helpful just to raise this educational bar in the field.
Yeah. Yeah, you definitely have to download the beta version from Prusa Slicer. So the 2.6 beta, it works fantastic. It's not a slicer for the faint-hearted, so they haven't released it yet.
Okay.
But it's you now have the ability to have tree supports. It has a lot of new features that are very interesting in compared to the one they released, the 2.5.2.
Mm-hmm.
The new beta I think it's 2.6.0 beta. It works fantastically. Also to configure it other machines, it's very nice. You can even slice your Kratos or whatsoever if
Yep.
you would like. Once your setup is done, it really works, and it has nice new features.
Very
I
nice.
found out a few days ago also, but yeah, it's fantastic. It works. Yeah.
I'll have to download that this afternoon. Awesome.
Yeah. Credits to the guys from Prusa who are doing that. It's fantastic. What they are having is nice. Yeah.
Yeah, oh, I've loved Prusa Slicer. There are a lot of features in there that I've gotten some really nice quality prints out of because I've used that slicer. We use Cura, Simplify 3D, Idea Maker for Raise 3D. We've done them all.
Yeah.
Prusa has definitely taken a step up, I've noticed in the past year or so.
Yeah.
So that's definitely nice to see, and continuing to add on these features because they're very useful to getting these successful prints, right?
Yeah. Yeah.
Is there anything else specific to the Blackbelt printer that you think we didn't mention yet, or you'd like people to know? It's now very available in the US. We are with our collaboration here between OMD 3D and Ascent Fabrication. We are offering this distribution service in North America and to all different categories of industries, whether you're into automotive, aerospace, you name it. We're getting into some continuous printing of foot orthotics in the prosthetics and orthotics field. And I have a couple more ideas for some continuous printing that is going to be very useful for this long, tight, build area.
Yeah.
So definitely reach out if you'd like a quote for your custom built by Peter and his team there, Blackbelt printer. And, we'll definitely run you through the whole gambit of options that we've talked about today, as well as maybe something we haven't mentioned. But I think we did a pretty nice job of going over that printer in a broad sense and what it's capable of. Definitely reach out if you're interested in that printer itself. And then also with our training services at Ascent Fabrication, if you're looking for that installation support, we'll come in for a couple days. We'll do the training on the black belt, run you through how to print your parts in whatever material that you want to print. On our black belt, we will actually pre-print some of those prints for you so that you can make sure that you can print your parts on this machine. We'll do that service for you as well. And maybe try to prove out that process before you make a purchase, so going into it you have no questions or concerns about having this printer in your facility. And then the ongoing maintenance and support packages will come in and service the machine as needed. If something's going wrong, we can have a technician there within a day or so, making sure that is completely serviced, your prints are working fine, and we figure out any issues along the way. So looking forward to getting out to more fields and trying to see where this printer has its applications. Peter, if anyone wants to contact you guys directly, what's the best way to do that?
I think the best is by email, by emails at sales@omd3d. I think that's the easiest way, or through LinkedIn. I think most people will find me on LinkedIn.
Yeah.
Will find me on LinkedIn. So and for the rest, actually, I have still two small things to say. There's no problem big enough we can't solve it anyway. So that's one go. And 90% of 3D printing problems are not caused by the machine. Mm-hmm. They are in between the screen and the chair. That's where 90% of 3D printing problems are located.
Yeah.
And that's a good thing, because that's something we can solve by educating people, by telling how to. And for the rest, keep calm and keep on printing. So
keep calm and keep on printing. I like that. We'll go into the weekend on that note.
Okay.
Thank you very much, Peter, for the time. I know you're a busy man and have a busy team behind you as well. So thank you for the time, and we look forward to working with you more through Blackbelt. Thank you again, everyone, for listening to Fabrication Friday. Joe Fairley here, owner of Ascent Fabrication, with Peter from OMD 3D. So thank you very much.
Bye.
Have a good one.